Welcome to the easiest introduction to game development with Raylib. If you are new to Raylib, you are in the right place to start your journey. In this video, I'll guide you through the installation process of Raylib on your Windows computer, and we are going to build a simple Raylib project from scratch. We will be using C++ with Visual Studio Code to develop a basic Raylib program featuring a keyboard-controlled ball. The entire procedure is very easy and should take no more than 20 minutes. Without any further delay, let's get started. First of all, we are going to download Visual Studio Code, a very powerful code editor. You can download it from this link. Select the installer for Windows 64-bit. After the download is complete, all we have to do is to install it just like any other software. After installing Visual Studio Code, we have to open it and click on the Extensions button, which is right here. We search for C++ and we install the C++ for Visual Studio Code extension by Microsoft. This extension will allow us to use C++ with Visual Studio Code. Visual Studio Code is just a code editor, so it does not contain a compiler and a debugger. That's something we have to keep in mind because we are going to need both a compiler and a debugger. Now let's download the Raylib library. All we have to do is to visit this website and click the download button here. You can donate if you want to support the developer of the library, but you can also download the library without donating. Now we have to choose the Raylib 5.0 Windows installer with the MinGW compiler. When we run the downloaded file, we get a warning from Windows. We have to click More Info and then click on the Run Anyway button. Now the installation begins and it is going to take a couple of minutes. After the installation is complete, in your C drive, you are going to find a Raylib folder where all the required files are located. This folder also includes a compiler and a debugger, so we don't need to install them separately. Another step is complete. The last step is to visit my GitHub repository and download a template C++ project that uses the Raylib library. This sample project will help you get started at once. I have included all the C++ files and all the settings required to work with Raylib, including the settings for the compiler and the debugger. If you find this repository helpful, give it a star so more people can learn about it and save some time when installing Raylib. Now we have to extract the .zip file on our computer. Let's unzip it on the desktop. We can use this folder as a starting point for every new Raylib project we do. Everything is set up and ready to use. Now, inside the folder, we're going to find a main.code workspace file. We just have to double-click it or open it with Visual Studio Code. We have to click Yes, I trust the authors button if prompted, and we are good to go. As you can see, the project is organized in folders. We have to open the source folder and double-click on the main.cpp file. This demo project consists of 3 files. To compile and run this project, we have to press the F5 key on the keyboard. Now, on the screen, a new window appears with a bouncing ball. Our setup works. Now, let's move on. We are ready to start developing our first Raylib program. Let's delete the ball.h and ball.cpp files. We don't need them anymore. Let's also delete all the code from the main.cpp file. We will start from scratch. Before we start, it is important to understand the structure of a game. Every game consists of 2 parts. The first part is where we define our variables and game objects, and we create the game window. In today's example, we only have one game object to keep things simple, a ball. The second part of the game is the game loop, which is responsible for checking for user input, updating the positions of the game objects, checking for collisions, and drawing the game objects. The game loop is like the heartbeat of the game, running repeatedly until the game is closed. So in today's example, in each iteration of the game loop, we will check for user input from the keyboard, update the position of the ball, and then we will draw it at its new position. All this will happen so fast that it will appear as a continuous movement. So let's start writing code. First, we have to include the Raylib library. Include raylib.h. This line tells our program to use the raylib.h file, which is like a toolbox full of helpful tools for creating games. Now we need to create a main function. Int main curly brackets, return 0 and a semicolon. This block of code is the main part of our program, where it starts running, and return 0 indicates that everything ran smoothly. Now let's create a game window. We will use the init window function of Raylib. Init window, parenthesis, and a semicolon. Now we need to tell this function three things. First of all, we need to tell it the width and the height of the game window in pixels. So let's enter 800, 800 as the first two arguments of the function. The third argument is the title of the game window, a text to appear on it. Let's enter this text. Quotes, my first Raylib game. That's it, our game window is now created with this line of code. The dimensions of the game window will be 800 by 800 pixels. Now in Raylib, each time we create a window, we then have to close it before closing the game. So here, before the return statement of the main function, let's close the game window. Close window, parenthesis, and a semicolon. Now let's run our program for the first time. As you can see, a game window has been created, but it is closed at once. Why is this happening? The computer executes the code line after line. So at first it creates a game window, then it closes the window, and then the program ends. We haven't done anything between these two lines of code. This is where all the magic happens. So let's implement the game loop. The game loop consists of three parts. First, event handling. First, we need to check for any events that occur in the game, such as quitting the game, a key pressed on the keyboard, etc. Second, updating positions. Next, we update the positions of all the game objects. We only have one object today, the ball, so we are going to update the position of the ball at each frame. Third, drawing objects. Finally, we draw all the game objects in their new positions on the screen. This step uses the Raylib graphics functions to render the objects on the display. We just have to draw the ball at its new position. Now let's implement these three steps. Let's write a comment first. Game loop. We start the game loop with a while loop like this. While, parenthesis, and curly brackets. The while loop will run over and over again until we close the game. The first thing we do inside the game loop is to check for any events. Now, inside the parentheses, we type the condition. Window should close, parentheses, equals false. The window should close Raylib function is a very useful function. It checks if the escape key on the keyboard is pressed or if the close icon of the window is pressed, and returns true if that is the case. So, if it returns true, the game loop ends and the window is destroyed. Now, inside the game loop here, let's enter some comments to help us organize our code. As we said, the game loop consists of three parts. Number 1, event handling, goes here. Number 2, updating positions of game objects, goes here. And lastly, number 3, drawing the objects, goes here. Before we run our game loop for the first time, we need two more functions. We will call them here, in the part where we draw things on the screen. First, we need to call the beginDrawing function. This function creates a blank canvas so we can draw our game objects on. Next, we need to call the endDrawing function, which ends the canvas drawing. Lastly, there is something else we need to do. We have to define how fast the game should run. We do so by calling the setTargetFPS function before the game loop. The setTargetFPS function takes an integer as an argument, and that integer is the number of frames per second that we want. I am going to use 60 frames per second. setTargetFPS, parenthesis, 60. That's it. If we don't define a frame rate for our game, the computer will try to run the game as fast as it can. So the game speed will depend on the speed of the computer. By defining a frame rate, we make sure that the game runs at the same speed on every computer. For this game, we defined that we want to run this while loop and update the game window 60 times per second. Now that a very basic game loop is complete, we can run our program again. As you can see, a new window appears. It has the correct dimensions, 800 by 800 pixels, and the title we defined. It is all black. There is nothing inside it because we haven't drawn anything yet. The important thing is that we can see the game window with the title and the dimensions we defined, and that we can reliably close the game by clicking on this X icon here or the escape button on the keyboard. Our game loop works. Now let's draw a white circle at the middle of the screen to represent our ball. Before doing that, let's see how computers draw on the screen. We just created a game window, and to draw on it, we use a coordinate system similar to the one taught in high school. Each point on this window has its unique x and y values. The coordinate system used in computer graphics differs from the standard Cartesian coordinate system taught in high school. In computer graphics, the origin of the display is located at the top left corner, with 0, 0 being at the top left. In contrast, the standard Cartesian coordinate system starts from the bottom left corner, with 0, 0 being the origin. In this system, the x-coordinate increases as we move to the right, and the y-coordinate increases as we move up. However, in the top left corner coordinate system used in computer graphics, the x-coordinate increases as we move to the right, and the y-coordinate increases as we move down. This means that a point at 10, 10 will be located 10 units to the right and 10 units down from the origin. We will be using the top left corner coordinate system in our program today. That's why it is important to understand the differences between these two coordinate systems. Now, as we said, we need to draw a circle at the center of the game window. What are the coordinates at the center of the game window? The window we created is 800 pixels wide and 800 pixels high. So the center will be at 400, 400 using our top left corner coordinate system. Let's use the draw circle function from Raylib to draw a circle at the center of the game window. We will add this line inside the drawing the objects part of our game loop after the begin drawing function. Draw, circle, parenthesis, and a semicolon. We need to tell this function four things: the x and y coordinates of the center of the circle we want to draw, the radius of the circle, and its color. So let's enter all this data into the function. So we enter 400, 400 as the coordinates of the center of the circle, and 20 pixels for its radius, and white in capital for its color. Raylib provides several built-in colors we can use at once. White is one of them. We will be defining our own colors later on. Now, if we run the game, we can see our ball is visible at the center of the screen. Cool. Let's now make it move. First, let's make it move to the right. It is easy. At every iteration of the game loop, we just have to alter the x-coordinate of the center of the circle. But we have hard-coded the x and y coordinates of the circle. Let's replace these hard-coded values with two variables. So, outside of the game loop, let's create two new variables. Int ball x is equal to 400. Int ball y equals to 400. Beautiful. Now, let's replace the hard-coded values in the game loop with these variables. So, in the draw circle function, we enter ball x, ball y here. Perfect. Now, as we said, we want to move the ball to the right. So we need to increase the x-coordinate of the center of the ball at each iteration of the game loop. So let's put this code at the second part of the game loop right here. Ball x plus equals 3. With this line of code, we increase the x-coordinate by 3 pixels at every frame. Let's run the game. As you can see, the ball moves, but it leaves a trace. What is going on? In every iteration of the game loop, our game executes these commands one after another. First, it calculates the position of the ball, and then it throws the ball. It does that 60 times per second. Each time it draws something on the game window, it does not erase what was drawn before. That's why the ball leaves a trace when it moves. So all we have to do is to clear the game window in every iteration of the game loop before drawing the ball in its new position. So before drawing the ball, we simply type clear background parenthesis black. With this function call, we tell the computer to fill the game window we are drawing on with black color, and this way we are clearing it. As you can see, if we run the game one more time, now the ball does not leave a trace, so the animation works as expected. Beautiful. But I don't like this black background. Let's make the background a more pleasing green color. In Raylib, colors are represented using a struct called color, which contains 4 components: red, green, blue, and alpha. The values of each component range from 0 to 255, where 0 represents the absence of the color and 255 represents the full intensity of the color. For example, to create a red color, we will create a color struct with the following values. Color red is equal to curly brackets 255, 0, 0, 255. The first 3 values represent the red, green, and blue components respectively, while the 4th value represents the alpha component or the transparency of the color. In this case, the alpha value is set to 255, which means the color is completely opaque. So let's create a green color. At the top of our file, in the definitions part of our program, we will define a color struct like this. Color green equals to curly brackets 20, 160, 133, 255. Now inside the game loop, we just have to change the color we clear the game window with at every frame. Clear background parenthesis green. Let's run the game one more time. As you can see, the background is now green and the ball moves as before. Now let's implement another cool feature. Let's add keyboard control so the player can control the movement of the ball. First of all, let's remove this line of code because we don't need it anymore. We want the ball to move to the right when the user presses the right arrow key on his keyboard. Raylib makes it very easy to detect when the user presses a key on the keyboard with the isKeyDown function, which takes a key constant as an input. So to check if the user has pressed the right arrow key on his keyboard, all we have to do is to type this at the first part of the game loop where we check for events. If parenthesis is key down parenthesis key underscore right and then curly brackets. Now we can just add some speed to the x position of the ball and we are done. Ball x plus equals 3. We can do the same thing to move the ball to the left. Else if parenthesis is key down parenthesis key underscore left curly brackets ball x minus equals 3. Let's test the program. Perfect. As you can see, the ball now moves either to the left or to the right depending on which key is pressed on the keyboard. Now let's add movement to the y-axis as well when the user presses the up or down arrow keys. We add another else-if statement. Else if parenthesis is key down parenthesis key underscore up curly brackets ball y minus equals 3. When we want to move the ball upwards, we subtract 3 pixels from its current position in the y-axis. Why do we subtract 3 pixels and not add 3 pixels? As we said before, the origin of the game window is the top left corner of it. So the top left corner of the game window has coordinates 0, 0. So if we want to move down in the y-axis, we have to increase the y coordinate. And if we want to move up, we need to decrease it. That's why we decrease the value of the ball y variable by 3 pixels when we need to move it upwards. Now, to move the ball downwards, we increase the value of the ball y variable. Else, if, parenthesis, is key down, parenthesis, key underscore down, curly brackets, ball y plus equals 3. Beautiful. Now let's run the code. As you can see, we can now move the ball around using the keyboard. Our first Raylib demo project is complete. If we close the game window and open the project folder, we can see an executable file has been created. It is called main.exe. If we double click on it, we can see our program runs. Perfect. We have successfully built our first Raylib project. Now you have all the basic knowledge required to build your first game. A classic game like Pong is a great first game to build. Pong involves not only moving a ball but also handling paddles, collisions, and scoring. If you are eager to dive into this exciting challenge, I have prepared a detailed tutorial that walks you through the process step by step. You can find it here. Also, if you want to be notified when I release new Raylib videos, be sure to subscribe in order not to miss them. Thanks for watching this video. I'll see you next time.